Guys, here's a look at the solutions for the 3 homework questions from page 629. So, on the first question, we were supposed to decide what's the shape of the sampling distribution for the difference between these two sample proportions. So we know the shape of the distribution of the differences between these sample proportions is approximately normal, and that has to do with the normality condition. So for the child mix, for that situation, we're taking a sample size of 50. The success rate is 30% red jelly beans. The failure rate is 70%. So both of those values are greater than or equal to 10. And it's the same thing for the adult mix. So that sample size is 100. The success rate is 15%. The failure rate is 85%. Again, the expected success and failure counts are both 10 or more. So what's important to remember is the sample proportions for the child mix and the adult mix for the individual p hats. They are approximately normal, and this is about a difference, and a difference is a linear transformation. So we're taking a linear transformation of two variables that are already approximately normal. So the difference is also approximately normal. A linear transformation preserves the shape of the original random variables. So if you want to find the mean is not very hard to find. It is the population parameter for the child mix. Take away the population parameter for the adult mix, 30% minus 15%. So the differences have a mean of 15%. The standard deviation is a little more sophisticated, but you can find that by just using the formula from the formula sheet. So here's the work for the child mix, the 30% times the 70% divided by 50. So here is the work for the adult mix, 15% times 85% divided by 100. So that standard deviation is about 0.074. So something interesting to think about here is, why is there a larger sample size required for the adult mix? It's twice the sample size. Well, it's in order for the normality condition to apply for the sample proportions from the adult mix. So notice, if we use the same sample size as for the child mix, we would get an expected number of successes of only 7.5, and that's less than 10. So the sample size for the adult mix had to be larger than for the child mix. So going to question number 5. So in the next two questions, the conditions are not met. The question is why? So the first condition involved, you have to be using random samples. So first of all, random samples of babies were not taken from East and West Woburn. So if we wanted to do this as an observational study, we would have to have random samples from both sides of Woburn, Massachusetts. Now, the other thing, something to think about, they were trying to say in this study that the chemicals in the water are causing the illness, are causing the deaths of these children. So if you want evidence of cause, technically, you do need to be doing an experiment, and this was certainly not an experiment. So the randomness condition, if this had been an experiment, would have had to have been that families were randomly assigned to live in either East or West Woburn, and that's absolutely not true. Families were not randomly assigned to live anywhere. You can't actually do that. So the randomness condition is the first and most important problem here. The randomness condition is not met. So in terms of independence, if we were doing an observational study and sampling babies from both East and West Woburn, we would have to believe that the number of babies in East Woburn was at least 4,140, and the number of babies in West Woburn would have to be at least 2,280. That's an awful lot of babies. I'm not convinced that that is true. Could it be true? Maybe, but I'm not convinced of that. Something to think about, if this were an experiment, technically in an experiment there isn't an independence condition because experiments do not involve sampling from a population. So look, if we were doing an observational study, we would be taking random samples out of both East and West Woburn. So I would want to believe that my random sample is no more than 10% of the population of babies in these two locations. So understand, in an experiment, because I'm not doing random sampling from populations, because we're we're doing random assignment to treatments. Technically, in an experiment, you don't have to worry about the independence condition. So in this question in general, the randomness condition has already failed, so the independence condition is not as important. We can go ahead and check the normality condition. So for East Woburn, the expected number is 16. That's greater than or equal to 10. The failure rate would be 398. That's certainly greater than or equal to 10. The problem is the normality condition is not met for West Woburn. So we only had 3 out of 228, and 3 is certainly less than 10. So if you look at the normality condition is not met on the west side of Woburn. So you could say that this question fails because of the randomness condition. You could also say that this question fails because of the normality condition. Question number 6, inline skaters. So this question, given the way the data were collected, it looks like this is supposed to be an observational study. So first of all, in terms of randomness, the data, it says the data come from a random sample of hospital emergency rooms. So the truth is that's not ideal. There's at least randomness in the way the data are collected, but it would be better if a random sample had been taken from inline skaters that do wear wrist guards, and then another independent random sample had been taken from those that don't wear wrist guards. There is at least some amount of randomness in the way the data were collected here. So we're going to go on to the independence condition. So we have to believe then that 10 times 53 are 530. We have to believe that there are at least 530 inline skaters that wear wrist guards that we could have sampled. And same thing for the number of inline skaters that don't wear wrist guards. We have to believe that that population size is at least 1,080, or 10 times our sample size. So if you believe that, then it's on to check the normality condition. So the number of wrist injuries wearing wrist guards, this is the problem. So n times p here ends up being 6, and that's less than or equal to 10. So the failure rate 47 is greater than or equal to 10. That one isn't the problem. The problem is right here. So the expected number of successes on those people wearing wrist guards is too low. It's less than 10. So the normality condition is going to fail for people that don't wear wrist guards. So the expected number of successes is 45. The expected number of failures is 63. So the conditions are met for the don't wear wrist guards group. The conditions aren't met, though, for the wearing wrist guards group. Bottom line, when you are in a 2-sample situation, actually when you are in a 1 or a 2-sample situation, we will have randomness conditions, independence conditions, and normality conditions. And for us to use the methods of AP statistics, we need all of those conditions to be met. So going forward, it's going to be important to remember to check for randomness, independence, and normality.